Welcome, my name is Anthony James, founder and CEO of LinuxAcademy.com and CloudAssessments.com. And today you're joining us inside of my office at our Keller, Texas location. We also have a Kansas City, Missouri location as well. We do have a little bit of construction going on, so our regular studio isn't available. And so you'll be joining us in our Christmas set inside of my office. Now today I'm joined with Christophe Lempeler, a VP of Product Strategy and Marketing. And we greatly apologize for the delay inside of this AWS security webinar. It was scheduled to be a week ago. However, I was exceptionally under the weather and couldn't even speak. So we do have a lot of great information for you, and we for certain will make up for the delay. And I'm going to go ahead and let Christophe Lempeler introduce himself and get started.
Sure. So thanks, Anthony. And like you said, my name is Christophe Lempeler. And on this slide, we actually have introductions. So briefly about me, I am, like Anthony said, a VP of Product Strategy and Marketing here at Linux Academy and Cloud Assessments. Before that, I was the founder of Scale Your Code, which is a podcast where we interview experts on how they run technologies in production. And so using all of that knowledge and also using experience that I have running production applications in Amazon Web Services and also with AWS certifications, what we're going to do today is we're going to give you a higher level overview of Amazon Web Services security, because as we've all seen in the news recently, there's been a lot of data leaks or just issues here and there, even from small to large corporations. So this is a big issue, if I'm being honest. And so just understanding the basics of it can really protect your business against these kinds of issues. So that's a little bit about me. And if you're interested in learning more, you can always follow me on Twitter at Christophe Lemp. And also on LinkedIn at Christophe Lempeler on LinkedIn there. So, and back to you, Anthony.
Yeah, and Christophe, the founder of Scale Your Code, and we're very excited to announce that ScaleYourCode.com and CloudAssessments.com have actually joined the LinuxAcademy.com membership suite, meaning if you have a team account or an individual account, you automatically receive access to both of those as our complimentary suite of training products. And you can follow me on Twitter at Anthony D. James, and also search for me on LinkedIn as Anthony D. James as well. And so let's go ahead and get started on this security webinar.
All right, so the first thing we'll cover, and this just gives you an overview of everything we'll cover in this webinar here, but the first thing we'll cover is identity and access management. From there, we'll move into data protection. After that, we'll go to detective control and incident response. And then finally, we'll wrap up with infrastructure security. So let's get started with identity and access management, which I might refer to as IAM or even IM. So if I say those words, that's what I'm talking about. Now, when it comes to IAM, the first step I like to cover is going over users, groups, and policies. The reason for that is because they're the bread and butter of how to get started with Amazon Web Services, how to set up different accounts for your team, for your developers, for your financial officers, whoever it is that needs to have access to your resources in Amazon Web Services will likely need to have a user that they can access. And so that's what a user is. A user basically consists of a name and credentials, and it represents a person or a service that can be used to interact with Amazon Web Services. So that could be the console, that could be all kinds of different resources that you have in there. Those users can have access keys, passwords, and policies. So those access keys can be used for a number of different reasons, but primarily what they're used for is to authenticate that user. So if, say, Christophe as a user in your account has certain policies attached to it that gives it certain access, then Christophe can use those access keys in his applications or via the command line interface or any other method like that, and he can have access to whatever those policies says that he can have access to. And that we can also use a username and password in order to just log into the console itself. So that's kind of what users are. And after we go through these points here, what I'll do is I'll switch over to the Amazon Web Services console so that we can actually see what that looks like in the console itself, and you can take a look at that.
And one of the things, if you don't mind, Christophe, one of the things that is super important from a security standpoint is obviously we're going to learn the basics of IM users and policies and groups. However, from an enterprise standpoint, if you're a financial technology company, you most likely have a lot of people that might need access and you're managing users. Now, from a best practice perspective, most likely you have an on-premises identity management solution already, such as Active Directory. Now, one of the best things that you could actually do from a security security standpoint, instead of managing a second set of users inside of IAM, you'll want to actually use SAML integration, or you could use Active Directory Connect, which is an Active Directory service or a simple AD service as well from Amazon Web Services, in order to connect your on-premises identity management to Amazon Web Services and only have a single place where you're managing those users and that access into AWS itself. One of the best things you can do from an enterprise perspective.
Yeah, like you said, if you're an enterprise perspective, that's very helpful. If you're just trying to test Amazon Web Services, you're just getting started in it, or if you have a smaller business, whatever the reason is, if you don't have time to set that up, you can still have access through users like that. So you don't have to worry about setting that up from the get-go. You can kind of play around and see how it works. And then once you're ready, you can make that migration over. Now, once you have users in place, as long as, even if you have one user or multiple different users, one best practice that I highly recommend is using groups, because you can actually have a group act as an umbrella over a group of users. For example, say that you have 10 different developers, and all of those developers need to have the same kind of access. Instead of creating policies and tying those policies to the user one by one, you can create a group and you can assign those users to that group, and then you can assign one or more policies to that group, and those policies will automatically be applied to those users. So that gives you one central location to manage all of those policies and all of those users, and you don't have to manage it one by one. It's a very, very helpful feature.
And on AWS, one thing to remember, and specifically as you're doing groups, you might have multiple set of groups, because what you want to do is you want to make sure whatever set of users are accessing your AWS environment have least privilege allowed. Now, this is kind of an AWS concept, but it's a general security concept in general, which basically means if a user doesn't need access to do something, don't let them do it. So don't attach a ton of policies to specific groups for users that don't need it. So you want to get pretty granular in your groups, but still that prevents you from having to get super granular in your users and managing 400 users, but instead you're managing a set of groups. So always adhere to that least privilege policy and give the least amount of privilege to anybody inside of that environment as required to perform their tasks.
Now, I've been mentioning the word policies over and over again, and the reason that is because policies are crucial in IAM. What a policy is it gives permissions to whatever it's attached to. So it could be attached to identities, which could be a user or even a resource. And there are two main types of policies. There's the identity-based policy, which can be attached to an identity, like a user, role, or group, as we've been talking about. There's also a second major type, which is called the resources-based policies. And these can be attached to specific resources, not all resources, but some of them can. Like Amazon S3, as an example, you can attach these policies to Amazon S3 resources in order to grant permissions. And we'll actually talk about that a little bit later when we move through and talk about data protection specifically. So Anthony, unless you have anything to add, I'm going to move over to the console real quick, and I'm going to walk you through and show you what that looks like inside of Amazon Web Services. So we've got an account created here, and this is just a test account. And you might notice in the top right corner, it says Christoph at, and then these digits. And the reason it says that is because I'm actually logged in as a user named Christoph in this account right here. So that can kind of give you an indication of what I'm doing here. Now, if I go inside of IAM, turns out I have administrative privileges, therefore I have access to all of these features and services. But that may not always be the case. So not everyone has to have access to this panel right here, which is where you manage most of your access policies and whatnot. So, but I do because I'm an administrator. So now if I look at this, I've got security status as a main panel here. And you'll notice we've got green check marks and we also have exclamation points. The green check marks means good or it's been done, which is good. The other ones means, hey, watch out, there's something that you haven't done here. And what these are, they're best practices right out of the box. So as soon as you set up your account, AWS wants to give you hints as to what you should be doing in order to secure your console, your application, or whatever it is. In this case, it's to secure our entire account. So the first tip that they give you is to activate multi-factor authentication on your root account. Now, this is a best practice. Obviously, I don't have it turned on right now, otherwise this would be a green check mark. But usually you want to make your users turn that on, even if it's a little bit of a hassle for them. That just provides another layer of security, and it's always a good idea, in my opinion.
And when you're thinking about root accounts, one of the best things to do is first create your AWS account, which you use a root account, which is your email address, and then create yourself a user. And do not use your root account again unless you absolutely have to. So your root account will have multi-factor authentication enabled on it, which is your hardware device that gives you a simple token that allows you to log in during specific, or it's a one-time event type extra password. And then enable multi-factor authentication on your IM user, and also turn on that policy for your other IM users as well.
Yeah, exactly. And the next point is create individual IM users for the very same reason that Anthony mentioned. You don't want to use the root account at all. Once you set it up, you just want to move over to users. It's just a security best practice. And then again, it talks about using groups to assign permissions, which we haven't done in this account. So what we're doing here is we're kind of showing you the do's and don'ts and why it's important. In this case, we don't have any groups created or any users assigned to those groups, as I'll show you in just a second. Then we can also apply an IAM password policy. We haven't done that here. I'll also show you how to set up account settings that can let you control what kinds of passwords are allowed for your users, whether you want special characters, length, rotation, all those types of useful things. And then finally, rotate your access keys. We were talking about access keys earlier. These can give you your application, your user, your command line interface access to your resources. And so it's very important that you rotate those access keys on a fairly frequent basis. And that frequency is honestly up to you. It kind of depends on your own policies and how you want to do that. But regardless, you should do it.
And when you talk about access keys, one of the things we will learn here is a best practice and even actually not using access keys. Because when we think about security and think about cloud, what we always want to do is also think about automation. We want to make it as easy as possible to manage our environment and reduce any of those loopholes from lack of processes put in place. So think automation, and we'll get back to that, but it's something called roles as a quick teaser as we move forward.
So let's move over to users real quick. I'll just brush through this as we have to keep moving along. But here you can see we have multiple different users, and we have information about the access key age, password age, and all of that information there. We can click on an individual user, and here we can see that Christoph happens to have administrative access as well as IAM user change password access because he has these policies attached to the user. We are not assigned to any groups here, and we can access security groups. Security credentials. So here we can manage access keys, we can manage SSH keys for AWS commit, etc. We can also control the assigned MFA device, so MFA multi-factor authentication as we mentioned earlier, and just more information about passwords. We can also look at Access Advisor, and we'll talk a little bit more about services that give you insights into what your users or services are doing. But here is the Access Advisor that says, okay, this user accessed these services, and here's the policies that granted that access, and here's the last date that they accessed that service.
And we talked about automation just a few minutes ago. Now, two things. One, IAM in itself is a global type service. So it doesn't matter the availability zones that you're working out of or the regions that you're working out of. It's just complete access to your AWS account. Now, the other side of that is this information you see here is not only accessible here. What AWS has done is they've created tools such as AWS CloudTrail, which actually empowers you to see all of the API calls that are given by a specific user. And combined with CloudWatch events and log streams, you can actually create your own custom notifications. Let's say that you want to know anytime anybody accesses an EC2 API key, opens up the EC2 console, so on and so forth. You can be notified that. Or anytime somebody actually logs in the IAM console or the AWS console itself, you can have a notification on that by combining AWS CloudTrail, CloudWatch, and Simple Notification Service in order to do that. Again, great best practices specifically for compliance because you can monitor everything that's done within an environment because of the API access keys and CloudTrail and all the API calls.
So next we talked about groups, and as I mentioned, we don't have any groups here, but we could create groups, and then we could give it a name like developers, administrators, whatever it is, and then attach those users to that group, also attaching policies to the group, and again, that automatically applies throughout. The last thing we mentioned was policies, and so here, if we go to policies, we'll see that we have AWS managed policies, so they've already created some out of the box to help you out. You can also create your own policies and manage your own policies all from here, or even, if you're not using the Amazon console, the AWS console, you could also use the command line interface or automate a lot of this stuff.
Be super careful when you're using these to make sure that you're still adhering with the least access privilege for the user, because these are generic at times, so sometimes it will require your own custom policies.
Yeah, absolutely. That's definitely something to look into it. It might be easier to get started, but don't leave it that way. Really fine-grained control it. All right, so moving on, we are then going to talk about roles. Do you want to take this over, Anthony?
Absolutely. So I kind of hinted a few minutes ago about not using access keys unless required. So if you think about building an application, we're going to give a picture upload application because that's the easiest one. Your application runs on an EC2 instance. That EC2 instance, an application, you upload a picture and it sends it to Amazon S3 for storage. Now, you might be thinking, okay, in order to use the Amazon SDKs, in order to upload a picture to the S3 bucket, I need to have access keys, or my developer needs to have access keys. And that's actually false. You don't ever, in terms of best practice, if you're running the application on AWS. Now keep in mind, there is a difference between running the application on the EC2 instance and running it on premises. If you have an application on premises that needs to communicate with AWS, you do need to use those access keys. However, the ideal thing would be to take that application and put it on an EC2 instance and actually assign what's called a role to the EC2 instance. And you do not put any access keys within that EC2 instance. And as long as you're using the Amazon SDKs to communicate, anytime a request is made to communicate with an AWS API, what happens is the Amazon SDK automatically communicates with something called Simple Token Service, and it retrieves a temporary set of API access keys for your application automatically, and it can cache it all the way up to 12 hours, I believe. And then once it's not cached, it will make that request again. So again, you don't have to worry about rotating access keys. You don't have to worry about if a developer leaves or revoking that type of access. So roles are a huge concept inside of AWS, and we're going to see them over and over and over again as we work and learn AWS itself. So always use roles when possible and use them on EC2 instances or wherever else they're required.
And some other examples down at the bottom there, we have cross-account access. So for example, we have a lot of different AWS accounts here at Linux Academy. So one way that I can manage those is by hopping around using roles to access another AWS account instead of having to have 100 different access keys or even usernames and passwords. I can just assume that role. I give up my current policy access, and I assume that new role with its own policy access. So that's kind of how that works. Another one that we could have is, again, mobile application that is, instead of having to hard code those access keys inside of the application itself, you can just assume that role through the application, and that will give you the proper policies that you're looking for.
Using federated services. So for example, using the AWS SDK, you could use Facebook where it could log in, get those temporary permissions by assuming a role, and be able to give that mobile application access to perform things like communicate with DynamoDB or AWS Cognito or Amazon S3. And you don't have to embed access keys inside of the mobile application, which we all know if you develop any type of mobile apps, it can take a turnaround time period in order to update that, which would increase the risks of potential downtime as well as security issues. So these roles are super important and can be used all over our application architectures.
So before showing you roles in the console, let's move over to account settings really quickly, since that's a quick one, and then we'll hop in there. But again, we talked about password policies, rotating passwords, setting a length, setting the strength of it, and a lot of different organizations have their own requirements for passwords. In this case, you can set that at the account level using account settings. So let's hop over to the console itself, and then we'll go over to account settings first, and then we'll backtrack to roles. Now, in the account settings, you can set the password policies. You can require at least one upper character, lowercase character, etc., including the length of the passwords, which, as you know, is very important. So you can set that up here. Then going back to roles, this is where we can create some of those roles, and you can just create all kinds of different roles that you need. You can assign those policies to the role. It could be a cross-account role. It could be a role specific for EC2 instances, like Anthony was saying, that need to have access to resources inside of Amazon S3 for whatever reason. This is where you can create these roles. And sometimes also, if you're using a service, for example, I'm just thinking of Amazon EMR, where you have to create, you're trying to create a deployment or whatever it is, and you'll need to have specific roles created for that. Sometimes Amazon Web Services will actually help you create those roles through the console in order to make it easier for you. But again, you might want to go back sometimes and look at the policies that it automatically generated, because you may want to tweak those just a tad bit. So, think about it that way when it comes to roles. They're very crucial when it comes to using Amazon Web Services and those services.
And you'll even see service-based roles where, for example, different AWS services will need to have a role in order to communicate with each other. And again, for security, automation, and communicating and tying things together is going to be key for us inside of our architectures.
Yep. Now, when it comes to IAM, honestly, we could be spending multiple webinars on this topic. It's a huge topic, especially when you go into policies, roles, all of that. It's a very, very big and very important topic. So if you're interested in learning more about IAM and you want us to cover that in more depth, keep in mind we'll be doing more of these webinars. So just let us know, send us an email, give us some feedback, and we can cover it in more detail. But right now, instead, let's go ahead and move forward and let's talk about data protection.
Well, and shameless plug, we also have training material on IAM in in-depth fashion, as well as certification material at Linux Academy and cloudassessments.com.
Yeah, absolutely. Now, we talked about resource-based policies earlier in addition to identity-based policies. And in this case, we're going to talk about S3 bucket policies. So even if you have the proper IAM user policies, so Christoph has the proper policies that restrict access, or it doesn't specify access, which is a default deny. So you've got denies, you've got allows, and you have explicit denies. If you don't explicitly allow, then it just defaults to a deny. But if you explicitly deny, it overrules everything. Now, in the case of my user, say I have a policy attached to my user, that policy doesn't mention anything to do with S3 bucket policies. By default, it will deny it. However, if we then create a bucket policy that gives me access to that, then I could still have access to those resources inside of Amazon S3. So you might think, okay, this person's not going to have access to S3 resources in this bucket, but if somebody messes up the policy, that will not be the case. And that is sometimes why we see in the news that XYZ Corporation had a data leak or somebody had access to the S3 bucket because it was wide open to the world, or it didn't have the proper policies blocking access. And that's why you have to be very, very careful.
What's really cool about bucket policies, specifically from a security standpoint, is the granularity of permissions that you can actually put in there. For example, I could create a bucket policy that says only traffic coming from a specific VPC can access contents within this bucket regardless of other permissions. Alternatively, we can set IP address ranges. So let's say you were using S3 for static website hosting for an intranet. You could actually specify that so only data coming from your external router would be accessible through that bucket policy. And we also see one of the most common places when we create a CloudFormation template, the bucket policy being created, and I'm sorry, not CloudFormation, but CloudFront, where we see the bucket policy being created with CloudFront that gives CloudFront permission to access that data within there and not necessarily open it up to everybody in the world as well. So bucket policies are super important as it relates to those granular different types of securities.
Let's take a look at S3 bucket policies in the console here. Let's go over to Amazon S3, and then we'll just pick one of the buckets that we have in this account. And from there, we can look at permissions. Now, first you'll see access control lists, and we'll cover ACLs in just a moment. But if we switch over to bucket policies, this is where in the console that you can define them. You can also define them through the command line interface or other API calls that have access to this. Now, when you're trying to create a bucket policy, it's a really good idea to take a look at the policy generator, because from here you can determine what access you want to either allow or deny, what principal. And like Anthony said, this could be a number of different principles, like a user or another service or things like that. You have the Amazon S3 service here, and then you can select actions that you want to either allow or deny. In this case, we want to delete the bucket action, or get bucket policy and get object, just for an example. And we can also specify a bucket name and a key name, which would be like a quote-unquote folder or even an object name. In this case, I won't specify one at all. And then if I fill all this information out, I could actually add the statement and then generate the policy. I could grab that, I could copy and paste it inside of this bucket policy editor. I could save it, and that will apply at the bucket level. So that's where you can kind of get started with bucket policies. Even if you don't really know how to create those policies by hand, you've got the policy generator right here.
And one thing that we also need to remember from a financial security standpoint is financial institutions Data integrity is super important, right? So we might upload financial documents to Amazon S3, but not only do we want to make sure that that is secure data, we want to make sure from a standpoint of security that it also cannot be deleted. So we can actually combine together multi-factor authentication that requires a multi-factor authentication for the delete API call to an Amazon S3 object. So if somebody doesn't have that device, they can't delete it even if they attempt to do it, and you bet it would be logged in AWS CloudTrail that they have attempted to do it. So lots of granular levels of security, lots of different options as we relate to financial security as well.
So now let's move over to access control list. Now if you just quickly glance through this, it kind of seems to do the exact same thing. You can give access to the bucket, you can give public access, you can control those kinds of things. So how are bucket policies and access control lists different? Well, AWS says that the access control lists are actually a legacy access policy option. And the reason for that is because they're quite limited. You can only use, or you can use ACLs to allow basic read and write permissions to other AWS accounts, but not users inside of your account. Whereas with S3 bucket policies, you can grant read or write access to users inside of your AWS account, which can be very, very helpful. So in this case, ACLs are a legacy access policy option. Now moving on, another very important things when it comes to data integrity and data security and protection overall is encryption. So what can you do to encrypt your data and secure your data, whether it's in transit or at rest? Well, with Amazon S3, we have access to both. And in order to store data on S3 or in S3 and have it encrypted, we can turn on server-side encryption. And what this does is, as soon as the object hits Amazon Web Services or Amazon S3, they'll take it, they'll encrypt it, and then they'll store it encrypted on disk. As soon as you pull that object out, it will be decrypted and given back to you. Now, so that works. You know, you can do that in Amazon S3. Alternatively, you could also encrypt it on your side and send it encrypted if you wanted to. At that point, all you have to do is just manage the encryption on your side. Whereas if you do it with Amazon S3's feature, then they do it on their side, which can make it easier.
Except for on the Amazon S3 feature, if we enable server-side encryption at rest, if I have permission or whoever has permission to download that option, that object is going to be decrypted at that call.
Yep.
So if you want to ensure end-to-end encryption where somebody needs a key to decrypt it off of Amazon S3, you'll want to hear what Christoph has to say next.
Yeah, so say you're sending the data over the wire, right? I mean, anybody could sniff that traffic or try to see what's going through the wire and try to pull that object out. So a lot of times people want to encrypt the data before it's even sent over the wire. And you have a couple options when doing that. Again, you can either do that on your end, you can encrypt the object and send it to Amazon S3 already encrypted. You just have to manage the encryption itself. When you get the object back, you have to be able to decrypt it, which can be a pretty big load, right? You have to set all of that up and can be pretty complicated. However, Amazon S3 also gives you an option, or actually Amazon Web Services Key Management System gives you an option that lets you encrypt it using their encryption methods. So they'll send you the information you need, your application can encrypt it using AWS KMS and what they send you, and then you send it over the wire and they'll take care of that encryption end-to-end for you. So that can make it easier to manage. This is totally up to the organization. If you're interested, do a little bit more research and see the pros and cons of that. Some organizations really want to have tight-knit control over their data encryption, so they may not be okay with that, while others won't care, and it'll be fine for them.
And these are S3 options and AWS options for encryption. Obviously, that some firms have their own encryption method where they're going to encrypt it before they send it up there, and then only they can decrypt it on the back end as well, and that's also an option.
Now, when it comes to sending data across your application, for example, say you're using AWS load balancers and then you've got web servers in the back end there, how do you do that? Because we talked about Amazon S3 encryption, but how do you encrypt data if you're sending it to your web servers or other AWS infrastructure? Well, there's a service called AWS Certificate Manager, and it's very helpful in provisioning and managing and also deploying SSL and TLS certificates. So what that means is you can actually deploy these certificates to your load balancers, and you can also encrypt data that's flowing through CloudFront, which is their CDN service for data distribution, as well as their API gateway service, which you can create APIs through, which means you would be sending data back and forth. So you have the access to AWS Certificate Manager. Of course, you don't have to use that Certificate Manager. You can do that with another service if you want to, but that is available for you, which makes it easier. All right, so we talked about that kind of data protection. There's one more type that we want to cover, and that's security groups. Security groups are a huge topic because they act as virtual firewalls that can control inbound and outbound traffic for your EC2 instances. So those are your servers. Obviously, you want to be really careful as to what's coming in and going out of those servers. So how do you do that? Well, with security groups. You can create custom rules in the security groups that determine the source and destination, and that could be an IP address, which could be IPv4 or IPv6. That could be a CIDR block, or it could also be another security group. If you want to allow access to a cluster of instances from another security group, and that other security group could have another cluster of instances, you can absolutely do that. Next, you can also control the protocol. This, for example, could be TCP protocol. The port range, again, example 443 or 80. So 443 would be HTTPS, 80 would be HTTP, and this could be for a web server that you have running. And a relatively new feature also allows you to leave comments. It seems like a silly feature, but that's super helpful when you have a ton of different security groups, because unless you're looking through all of the different rules, you just want to be able to read that description and say, okay, this is what this is for. So that makes it very easy. All right, anything else you want to add, Anthony, or can we move on to detective control?
Let's go ahead and move on.
All right, perfect. So the next topic is detective control and incident response. And we'll start off with CloudWatch events and logging. And we've got a graphic here that kind of shows you how you can revert and receive notifications about changes to Amazon VPC security groups. So we just talked about security groups overall. There's also a service called Amazon VPC, and we'll cover that in just a little bit. But you can also have security groups in the Amazon VPC service. But what if somebody changes either an ingress or even egress rule inside of your security group, and that shouldn't have been authorized, or you didn't want that to happen? Well, you can actually use a service called CloudWatch, which is an Amazon Web Services monitoring service, crucial service if you're using AWS. And CloudWatch has something called events. Those events can be triggered when something happens. So in this case, Christoph goes in and modifies the ingress rule. That triggers an event in CloudWatch, and in our scenario, that then triggers a Lambda function. And AWS Lambda is a serverless service, so that would automatically be triggered by the CloudWatch events. You don't have to manage any of the infrastructure for it. Once Lambda is executed, it will look at that ingress rule, it will pull it down and keep it there if you want it to, depends on the code that you want to have, and then it will revert that security group back to the original rules that it should have, and then it could also send an email or even SMS notification to whoever you want to notify. And it could also say, okay, this is the rule that was changed, this is what it was changed to, and it has been successfully reverted back. That way, whoever's in charge of that can take a look at it and say, okay, so Anthony requested this change, and actually, it's a really good idea to make that change. So let's go see what they had in mind, and I can go ahead and apply it permanently, or no, that was a stupid idea. Let's make sure it's reverted and move forward with that.
Why is this important? It's important for multiple reasons, and I actually want to draw your attention to two things here. Now, first off, from a financial standpoint, automation is key. We keep coming back to this, right? So not only can I be notified if this happens, but I also know that this application for no reason should not be having modified rules without maybe change process documentation, or at the very least, whoever's in charge of it should know about it. So if that happens through a developer or somebody with access that just went ahead and did it, or maybe your script went wrong and it went ahead and changed it to the wrong security group, it'll automatically revert it back. And from a compliance standpoint, this is big, right? So we have different methods in here. We have notification of changes, but we also have preventative measures that allow us to prevent changes from happening and jeopardizing our compliance certifications. Now, one big buzzword in the industry right now is serverless. Now, most people, when they talk about serverless, they're talking about taking an application and just making it serverless. Now, a lot of enterprises and a lot of other applications, specifically third-party applications that have to run on instances, can't just be made to go into serverless. And what I really want you to think about from a security standpoint and an automation standpoint is the fact that serverless can actually be plugged into your traditional architecture or to your AWS architecture with EC2 instances to provide additional value in monitoring. Now, Lambda allows us to write a lot of custom scripts. Now, to tell you a little bit about how they're doing this in the back end is CloudWatch events is nothing more than seeing the CloudTrail API events coming in. And again, it goes back where I can write my own custom regex that allows me to parse through different API keys that I can then integrate with Lambda if I wanted by writing a Lambda script that tells it to do something if something happens, and or just tying it directly into simple notification service. So at the very least, somebody can be notified if something occurs, or you can hit an automation endpoint with simple notification service as well. So what I really want to do is open your mind to the world of serverless within your server architectures, as well as using these tools for automation within your financial security, because this will help take your compliance to the next level. And as you have smaller teams and you think DevOps, but you have a lot more applications, automation is key to reduce human error. And as we know, in terms of security, a lot of the major security breaches are due to human error. And so these types of things help alleviate the amount of human involvement and human error possible. So AWS and serverless technologies are great for automation within the financial security industry.
All right, so let's talk a little bit more about CloudWatch logging and events. So logging is something that we haven't really covered yet, but let's say that you have multiple EC2 instances, and those EC2 instances are running some kind of application. It could be a critical application. It could be something that runs background jobs. Whatever it is, we usually want to have logging set up for those EC2 instances, and we want to be able to access those logs without having to SSH into the instance itself, right? That should give you a feed, or it should have something plugged up to it where you can easily search, look for errors, or even get notifications with those CloudWatch events when there is an error that occurs or even occurs too often. So we can set up logging with CloudWatch using their agent, and obviously there's other choices. If you don't want to use CloudWatch, their agent, you could also use other things like Splunk or whatever other service that you want to use, but CloudWatch does give you that ability to do that.
And again, real quick, if you think about this, one of the questions that I've been asked before is, how do I provide somebody access to go in and view application logs? And my question was, well, do they need access to the instance? And they said yes. That is bad practice. There's no reason for that. Using CloudWatch logs, we can take any file, any log file, whatever is being written to, and stream it to Amazon CloudWatch. Now, at that point, if you have tier 1 engineers or support people who need to see that log file information, you can provide read-only access to those log files within CloudWatch. Alternatively, you could do a lot more with it. You could use APIs to consume that in your own dashboards. You can tie it in with Amazon CloudWatch or Lambda, and let's say that you just want those reports inside of a specific document for archiving on premises, and use events in Lambda in order to automatically export that and download it on your on-premises environment. So CloudWatch Logs actually allows us to take our instances and do centralized logging without another centralized logging tool. And again, we can use regular expressions to parse some of that log data to tie into actionable automation with Amazon Lambda and simple notification service as well.
We also talked about CloudWatch events, and we saw that in the previous example, but that's something else that's really big with CloudWatch. An event can be triggered when something is detected, and it can cause another action to be taken. Like in our example, we had Lambda take an action to revert back and notify someone. So those are two really big features that we have access to with CloudWatch. And just keep in mind that overall, CloudWatch is an integral feature in Amazon Web Services, and it's oftentimes plugged in by default to other services. Like if you go and launch an EC2 instance, you'll see that by default it will launch monitoring, and you'll have access to see CPU utilization, network in, network out, and other metrics like that. And you can just keep an eye on it by default. And a lot of that is for free too.
And to talk about CloudWatch as well, you can use CloudWatch for your own application monitoring. You can use the CloudWatch APIs to build your own CloudWatch logs, of which you can then put in monitoring and metrics. So if certain thresholds are met, it will automatically use simple notification service to notify a team, and or again, you can tie into Lambda functions to invoke different automations. So again, super powerful tool for us and our security standpoint.
All right, Anthony, let's move over to CloudTrail.
Now, CloudTrail is really, we talked about this multiple times, so I'm just going to breeze through it. A CloudTrail is that thing that is exactly what it says is. It is a trail of everything that happens. Now, one thing that you need to be aware of is not all AWS services support CloudTrail. A lot of times they will release a new service and it will take a few months for them to turn on support for that. Now, when you go through and look at AWS CloudTrail, every API call, by who made that API call, whether it was access key or IAM user, as well as time and date that API call was made. Again, we can use different automation to tie this in, but what's important here is from a compliance and audit trail standpoint. Who did what, where, and why? What application did what, where, and why? And so we see that AWS themselves are tying a lot of things together by using CloudTrail and serverless technologies to create this automation. And that's super important, right? So we need that from a security analysis standpoint, resource change tracking, as well as troubleshooting. So again, very, very important for us in terms of compliance.
All right, and then let's move on to an example for CloudTrail where it shows you, again, we have the account activity that occurs. That is recorded inside of CloudTrail, so it'll record it as a record, and that's the activity that you'll see in the CloudTrail event log. And then you can also view and download that activity in the CloudTrail event history. You can also set it up to define an S3 bucket for storage of all those logs, because that can be a lot of information. So you can store that inside of Amazon S3, and you can secure that with, for example, S3 bucket policies, as we talked about. Then you'll have that delivered to the S3 bucket, and you could also deliver it to CloudWatch logs or even CloudWatch events. You could set it up where we have something like Elasticsearch that's you can use to search through those logs and find specific things. You can set up dashboards, beautiful dashboards, especially with CloudWatch. And yeah, you can just do all kinds of those things.
Absolutely. And then of course you'll tie in S3 bucket policies, maybe with Amazon Glacier, in order to do long-term storage of those logs. So if 4 years down the road you are under a compliance audit and they request that, it's easily accessible information at a low cost as well.
All right, the last thing we'll talk about in detective control and incident response is AWS config. Can you take that over for us?
Absolutely. And so what I'm really going to do here is kind of give you an overview and show you some stuff that we have set up in the console. There's kind of two components to AWS config. There's also AWS inspector that I'm not sure if we're going to talk about it, but I feel is important, so I'm probably going to try to talk about it. Unless that's on the next step.
It's on the next one, infrastructure security.
Okay, so what we'll do is we'll talk about AWS config then. So a lot of the times what we see from a security standpoint is we update our AMIs, our Amazon machine images, which are just virtual machine images, and we have specific things in there, right? Don't use this older version because it's not compliant. And so what we want to do is we want to make sure that we can be notified of specific components within our environment that are outside of compliance. There's a lot of resources inside of Amazon. How do we know, right? So if we go ahead and go over to the AWS console, and what we're going to see is AWS config. And so I'm going to very quickly just bring it up here real quick. And we have a few things already on here. And so AWS config allows us to see not only the number of resources that we have available, but the resources that we're doing, but we can create custom rules as well. And you can see I have 3 custom rules already put in here. Number 1, I put in a policy that says no S3 bucket should have public read permissions, right? That is where we get caught a lot, not we, but other firms get caught a lot, is somebody accidentally setting that. Not only if that happens, can we integrate in with other automated services that maybe go take that backwards or revert that change, but of that notification. But at the very least, what I can do is I can see this rule and it tells me which of our buckets that we have non-compliant here. And you can say that we have a non-compliant bucket there, which is just an external website. And then we also have approved AMIs. So we have specific EC2 instances that are allowed to be running specific AMIs. And unless they're running those AMIs, we can be notified of that. Again, big for security compliance. And then again, the other example that we have is CloudTrail enabled? Now, recently, AWS made the change that by default, CloudTrail is enabled, only to revert that change, I believe. So if it's default today, I do not think it is, but this is important on our accounts because CloudTrail, what does that do again? It monitors every single API call, whether I'm in the console or I'm making it via the command line or I'm using an SDK or whatever access or tool is being used to access that. And so that's very important for us. And again, there's a lot of different options we have for this, and AWS has a lot of custom rules as we have available here, and you can learn to develop your own custom rules as well. Right now, we're going to go ahead and conclude this webinar, and we're going to have another one that dives into infrastructure automation and security as it relates to using services such as AWS Config, Systems Manager, and AWS Inspector. Now, the big tease here that I want to tell you about is it does so much work for you, it's not even funny. It'll automatically update security things. It'll automatically run known vulnerabilities within your environment that's running this. It's super cool. So if you want to go ahead and register for that, we'll have it shortly. And we appreciate you joining us on this Security for Financial Technology webinar.
If you have any feedback or if you want us to do a deep dive in anything that we've covered so far, please email us back and let us know. Give us thoughts on other topics that you want us to cover. But I'm really excited to have episode number 2 on infrastructure security, and we'll also include some use case examples of how this can be used in either enterprise or small scale. So thank you all for tuning in, and see you next time.